obtain an expression for, you read the next question.
Obtain an expression for the athlete maximum displacement in the vertical direction, y in
Y
terms of v
maximum.
naught, y maximum in terms of v naught, degree naught, and g.
Okay. Now, earlier on, we derive an expression, a general formula, an expression for the horizontal distance, the range. Now they want us to derive the formula for the vertical height, the maximum vertical height here. Okay, the maximum height here, this distance here, the maximum distance, the maximum height. Earlier on, we have found out the time for the maximum height. How to find the time for maximum height? This is how we find the time. So by putting the horizontal component of the velocity equals to 0, we can find the time. Now this time is the time until the middle here, the time for the maximum height. When you multiply by 2, it will be the time until the 0 level again. So now we want maximum height, you just take this one, the first one, the t, not the 2t, right? Okay, so we continue here. Which formula we are going to use? We are going to use the v equals to v naught plus at. At the maximum height here, the vertical velocity is 0, so you put 0. The initial component of the vertical velocity is v naught sine theta naught, v naught sine theta naught. Then minus gt. G acceleration is negative g, t is the t. So from here, you can use t equals to v naught sine theta naught divided by g. So this is the time taken to reach the maximum height. Okay. Now, but it is only the time. What we want to find is the maximum height. That is the delta y, the vertical displacement. Now, which formula should we use? So we use the last formula here. The last formula here. Delta x equals to half v naught plus v multiplied with t. So the distance traveled is half the initial velocity plus the final velocity multiplied with time. Now applying this formula to the vertical component, the vertical component. So now delta x, the displacement is the vertical component displacement. Half is still half. The initial velocity is v naught sine theta naught, because the vertical, we are using the vertical component. So v naught sine theta naught. At the maximum height here, the velocity is 0. The final velocity is 0. Then multiply with the time. The time is v naught sine theta naught g. So it's this time here, the time we have found for the maximum height. So if you want to multiply these together, the 2 and the g, they are at the bottom. The 2 and the g, they are at the bottom. So at the top, what you have? V naught, V naught. So it becomes V naught square. Sine theta naught, sine theta naught. So it is sine square theta naught. So multiplying this together, we get this expression here. This expression is the expression for the maximum height, the maximum vertical displacement. This is the maximum height. So this is actually a general formula, right? This is actually a general formula for the maximum height. So make it a different color and color it bold. Then you can see better. Okay, so this is the general formula. So let's say if you know the velocity, the initial velocity, let's say 10 meter per second. So you substitute this number with 10 meter per second, and you know the angle of projection, let's say 45 degrees or maybe 20 degrees, you substitute inside this formula, you can actually find what is the maximum height the object can achieve. So you substitute everything, you will get the maximum height the object can achieve. So this is it. Any questions so far?
Questions?
Hmm?
No questions.
This,
No questions. I
no, huh?
understand. Hmm.
No, then we look at this problem here, the last problem. Now this last problem is projection at an angle, but this time it is at the top of a building, or maybe you can at a cliff, cliff or top of a building, you project it and you fall down until the ground level. From the top of the building until the ground level, or from the top of the cliff until the bottom here, right? So you read this question, example 3.5.
A ball is thrown upward from the top of a building at an angle of 30 degrees above the horizontal and the initial speed of 20 meters per second, as in figure 3.12. The point of release is 45 meters above the ground. A. How long does it take for the ball to hit the ground? B. Find the ball speed at impact. C. Find the horizontal range of the ball. Neglect air resistance.
Okay, right. So the there are two things given: the initial velocity of projection and the angle of projection. That's all what is given. Or another thing is the height above the ground, 45 meters above the height, above ground, 45 meters above ground. Okay, okay, right. So let's say you want to know or a certain what is the range here, the horizontal distance covered, then you have to, the condition is it must have traveled negative 45 meter, right? Because the height is 45 meter, so it must have sorry, it must have gone down, right? It must have gone up and come down 45 meters. When it has come down 45 meters, then it would have covered the range. It would have covered the range, right? So we use this condition to find. Okay. Another thing is, how long does it take for the ball to hit the ground? No, when it hits the ground, again, the condition is negative 45 meters. Now, negative 45 meters is the vertical component, right? It's the vertical component. So we are going to apply the vertical component here. We are going to apply the vertical component. All right. So this is the solution. So we consider the vertical component. And what formula are we going to use? We are going to use this formula, the second, right? The second formula. So the vertical displacement is the initial velocity multiplied with the time plus half acceleration multiplied by the time square. Now, am I doing this? I'm doing this to find the time of flight, right? You see, if you look at the vertical component, it goes up and come down. The vertical distance covered is negative 45 degrees. Now, the only thing that relate this vertical flight with the horizontal distance covered is the time. The thing that is common between the two components is the time. Okay, so I have to find the time of flight for this projectile, for the ball, and I use this time, I substitute into the horizontal component to find out the horizontal distance covered, right? Okay, so first of all, I want to find the time. Okay, so how long does it take for the ball to hit the ground? So I use this equation. Displacement equals to initial velocity times time plus half at squared. Now, if you consider the vertical component, the distance covered is negative 45. So you go down 45 here. So it's negative 45. I use the color to color it. Negative 45. Okay. The initial vertical component of the velocity, right? Initial vertical component, this 20 meters, 30 degrees. You resolve it horizontally is 20 cos 30. Resolve it vertically is 20 sine 30. So if you consider the vertical component is the initial velocity is 20 sine 30. Right? Sine 30 is 0 0.5. 0 0.5. 0 0.5 multiplied with 20 is 10. Is 10. So this half AT is half G. Half G is 4.9. So 4.9 minus 10t minus 45, which is the vertical distance, equals to 0. And it becomes a quadratic equation. So in order to solve the quadratic equation, you have to use the formula minus b plus or minus b square minus 4ac. So what is the b here? The b is negative 10. So negative 10, negative b is negative 10. So it's actually positive 10. B square is 10 square. 4, 4. Then A is 4.9. C is negative 45. Then divide by 2A. 2A is 4.9. So using your calculator, you can find two different time. So one of the time you have found using the negative number here, the negative sign here, will be a negative time. So it is not useful. So we just ignore the negative one. So you take the positive sign here. So positive 10 plus this number divided by this number. Answer is 4.22 seconds. Okay, so you use your calculator, you can check. So this 4.22 second is the time taken for it to go down until negative 45 meters. Why negative 45? Because this 45. And this is our starting point. So you go downwards, it becomes negative 45. So this is the time taken is 4.22 seconds. Next part, the speed, find the ball speed at impact. Now, if you want to find the speed, you have to find two components. Okay, two components. The horizontal component and the vertical component. Now, the horizontal component, this one, when you project at 20 meter per second, the horizontal component is not subjected to gravitation. Only the vertical component is subjected to gravitation. So the vertical component will change. Horizontal component will not change. So I record down the horizontal component that will not change here. Okay. So this is the horizontal component of the speed that will not change throughout the journey. The component that is going to change is this one, 20 sine 30. So I apply this equation here, V equals to V naught plus AT. So this V is actually the vertical component that is changing according to the gravitational pull. So the vertical component is V plus V naught plus AT. So the initial velocity is 20 sine 30. This is it, initial velocity. Minus 9.8. The time is this time here, 4.22 seconds. So when you use your calculator to evaluate this expression, it is negative 31.4. So here we have the two components, the horizontal component, which is not changing, and the vertical component, which is changing. And right at this point, it is 31.4 meter per second, 31.4. So we have to combine these two components. This one, this is 17.3, 17.3, which is the horizontal component. The vertical component is 31. This vertical component is pointing downwards because negative is pointing downwards, 31, 31.4. Okay, so they are in their respective components. It is not the the combined speed of the ball. So the combined speed of the ball, you have to use Pythagoras theorem to merge the two components together. You have to use Pythagoras theorem to merge these two components together. Like these two, they are the sides of a triangle, and the true velocity of the ball is the hypotenuse of the triangle, right? So merge them together, you use 17.3 square, okay, plus 31.4 square, this one, and your final answer is 35.9. So you use Pythagoras theorem to merge back the two components into the actual velocity or the actual speed of the ball. Oh, one part I miss out. So far, any question or not? So you know you
No
have to
question.
merge back, right? You have to merge the two components back to get the final velocity, the final speed at this point. The last part I didn't, I didn't type out. Okay, if can, then I clear this. Then we look at the last part. Okay, the last part is what? Find the horizontal range of the ball. Okay, the horizontal range of the ball is this one, this height, this length here, the x here. So the formula that we are going to use is delta x, right? Delta x, the horizontal displacement is the horizontal component of the velocity, v cos theta. Where is the v cos theta? Theta is here. Okay, v cos theta multiply with the time. Multiply with the time. Okay, so the horizontal velocity is fixed. It's not subjected to gravitational pull. So you just take the horizontal speed, multiply with time. That will be your distance. The horizontal speed is v 20, right? 20. The v is 20 cos 30 degrees. 20 cos 30 degrees. Yeah. 20 cos 30 degrees. And multiply with the time, 4.22. Can you use your calculator to find out how much is this? 20 cos 30, then multiply with 4.22. How much is that?
73.09.
Yeah, 73.09, correct. So it's 73.1, because the question they use three significant figure: meter, per second. Okay. Right. So any question regarding the range? This range here, this is called the range. When you want to find the range, because there's no acceleration, horizontal acceleration, then it's just the constant velocity multiplied with the time. Constant velocity multiplied with time. Whereas the vertical component, you have to use all this, all this formula here. All this you have to use. As if there's a constant acceleration, then you have to use this. If there's no acceleration, then you don't need to use this. Okay, so the horizontal component not subjected to gravitational pull, so you just use velocity times time. That will be the what meter per second? Meter, sorry, meter. This is the horizontal distance. Why I go and type meter per second? Delta x is the displacement, so it's in meter, right? Any questions so far?
No questions, sir.